everyone. Welcome back to another episode of Pen and Paper Programming. In the last video, we started talking about problem 4.3, which is reversing bits. If you haven't, please take a look at that. In that video, we walked through basically how we can take an integer and then reverse bits. So the example we gave was 1, 1, 1, 4 zeros and 1 would be returned in reverse, which is 1, 4 zeros and 1, 1, 1. And in that particular video, we explained this particular method, which takes an integer and then reverses bits. We walk through, again, take a look at it. So the problem, the solution in the book is basically using a lookup cache, right? And what I'm going to walk through right now is that how that lookup cache works when you don't have a single integer but perhaps many integers that you want to reverse bits. And in that case, instead of going through each integer one bit at a time, the book's example is basically using a cache which looks up 16 bits at a time and then reverses all the bits for a given integer, 64-bit integer, right? So I'm gonna just cover this up real quick, just so you know. This particular method is defined as reverse bits. Takes an integer, returns a value which is in reverse. So we're going to take advantage of that function when we actually populate our cache, right? We have a cache. This is all in Python. The examples that I'm giving is that we have a array which is reverse cache, right? And defining a method called build reverse cache, which iterates through from 0 to 2 to the 16th, right? And I'll explain why it is 2 to the 16, not 64, because the book is saying that we need to reverse bits for 64-bit integers. But in this case, we are actually creating reverse for integers that are ranging from 0 to 2 to the 16, which is 65,536, I think. But so it's not full for 64 bits. Anyways, we are iterating through x in range 0 to the 16th, and we are basically adding the value of reverse bits, which we call the method I just showed, passing in the x, right? When we call that, it is taking x and returning this reverse bits right here. It's returning the value in reverse bits, right? So we basically populate our cache here, and it is stored under reverse cache variable. So so let's talk a bit about why 2 to the 16, not 2 to the 64. When we are given a 64-bit integer, if you want to populate the reverse bits for every single one of them in a cache, it would be a huge number. I mean, if you can look it up, what 2 to the 64th power is, that's not something that you're going to be able to create reverse bits, cache, and store on your computer. It's a huge number of entries. But that said, if you were given, let's take a quick look at it, right? So if you're given 64-bit integers, let's say that we have 16 bits, 16 bits, 16 bits, and 16 bits, and just imagine there are 16 bits on each, and that totals up to 64-bit total. 64-bit, 2 to the 64, again, is a huge number. We're not going to be able to create a cache lookup for that. But that said, if you're going to reverse bits for a 16-bit, that's doable, right? It's only 65,000, around 65,000 entries. So what you can do is, if you need to reverse bits, what you really have to do is, let's say you have a lookup cache for the first, again, this is again the first 16-bit, second 16-bit, third 16-bit, fourth 16-bit, right? Let's get 1, 2, 3, and fourth 16-bit chunks. When you do that, you can take this 16 bits, let's say, again, I'm gonna say these are 16-bit, 1010, whatever. You can take that, and if you can look up the reverse of that, and all you really have to do, take this and, you know, look up the reverse, and what you need to do is you need to shift it. Where do you need to shift it? You need to shift it to, like, this is going to be the beginning of the new number. So this is the least significant bits here in the first chunk, and this is the most significant bits here. What you really need to do is you take the least significant 16 bits and move it to the fourth one, right? So the first one becomes the fourth, and of course what you do is you kind of reverse that. Now the number's in a reverse order. Now you take the second one and move it to the third one. This is the second one, and the third one and the fourth one. You reverse that, and you basically, when you do that, you're also reversing the bits on each one. When you do that process, you are basically reversing the bits using 16-bit lookups. If you were to give an example, 8-bit example, we're not going to be able to write down all 16 bits. Let's give an example with 8 bits, right? So let's say we have the first two most significant bits are 1, 0, then we have 1, 1, and then we have 0, 0, and then let's say 0, 1, right? So if you were to take, this is the first chunk, second chunk, third chunk, and fourth chunk. First, second, third, and fourth. We take the first chunk and we reverse it. What's the reverse of that? That's 1, 0. So we're going to move it to here, which is going to be 1, 0, right? 1, 0 in reverse. We take the second one and reverse is the same as 0, 0. It doesn't change. This is the, let's say this is the first one, this is the second one, and we take the third one. Again, that's 1, 1. This is the third one, 1, 1. And the fourth one is basically reverse of that would be 0, 1. The fourth one comes 0, 1, right? So if you read it in reverse, right? 1, okay, we're going to start from here, right? Let me show that. We have 1, 0, 0, 0, 1, 1, 0, 1. We just reverse it. That's the concept, right? When we take a look at our code real quick, first thing we did was basically create the cache for 16-bit chunks. So when you take a look at each chunk in the 64 bits, they are just numbers, right? They are ones from 0 to 65,000 numbers, and whether it's in the first chunk, second chunk, or third chunk doesn't matter. They are the same lookup cache. We need to generate it only for 16-bit. That's all. And we have this function which is given in the books, right? So the name in the book is different, but at the end it's the same method here. Is that the first thing we do is actually call this function to populate our cache. Mask size is 16. I will explain why. And bit mask is again, this is 16 bits. This is basically 16 ones right here in hexadecimal, and it's a very simple function where we have the variable y, which is constructed through looking up the caches. It looks complicated, but let me just quickly explain what's happening here. We have our cache, lookup cache, which is storing the reverse of each number. Reverse of 1 in 16-bit, which is 15 zeros and 1, is going to be returning 1 and 15 zeros in reverse, right? That's just one example, but we have all the reverse numbers in our reverse cache. So what we are doing is that there are 4 lookups here, which is appended by OR. So the way the OR works is that, just imagine each of these lookups is going to give us 16 bits, and we are basically concatenating them. So the first 16 bit, this one is going to give us the first 16 bit, this is going to give us the second 16 bit, third and fourth. We are going to add them up. I'm just going to give it one example. Let's say the first one returned 1, second one returned, we OR that with second one, which is 0, we OR that with third one, which is 1, and we OR that with fourth one, which is, let's say, 0. So eventually we are just ORing everything, and that's going to return us 1, 0, 1, 0. But this is going to be 16 bits. Each of these chunks, imagine 16-bit numbers, right? So in our reverse cache, we take our input, which is x. Let's walk through the first one. We are going to end it with bit mask. Our bit mask is 16 ones. This is FFF, basically 16-bit. They are all ones. When we do that, we are extracting the first 16 bits of x, the input, right? When you end with a bit mask, you're basically extracting those 16 bits. So again, going back to our examples, let's say that in this particular cache, we have, let's say, chunk 1, which is 16 bits, right? First 16 bits, second, third, fourth, right? This first expression is giving us the first 16 bits, right? And we take that, we extract that, and what do? We are going to left shift it by 3 times mask size. So we're gonna left shift this 3 times 16. That is 48, right? We're gonna left shift 48. So what that means is we are taking, and don't forget, we are actually doing a lookup, right? We take this number, 16 bits, we do the lookup, which is reversing this number, whatever it was stored there, and left shift it to the 4th position. When we do 48-bit left shift, it's going to basically bring the 16-bit chunk to the 4th spot, right? And the second one does same thing, something very similar, which is take an X, but in this case we don't want to do the first 16-bit, right? We want to do the second one, which is this one. And in order for us to extract that, we have to first right shift it to the least significant bit, which is basically so that the second chunk can become the first chunk. And then second becomes the first, and third and fourth, we take the second one and move it to the, the first 16 bits. And then same thing again, we extract it via ending with the bit mask. We extracted basically whatever the value was in the second chunk, and we do the lookup, which we get the reverse number, and then we're going to left shift it by 2 times the mask size, which is 32, 16 times, 32 bits. In this case, second one is going to be moved to the 3rd spot, right? First one moved to the 4th, second one is going to move to the 3rd. You get the idea. In the 3rd one, we do something similar. Now we're going to move the 3rd one, but in order for us to move the 3rd one to the first location, we have to move 2 chunks, which is 2 times 16, right? 2 times the mask size. And then when we moved it to the right location, we bit mask it, which we extract basically the 16 bits value, which was stored in the 3rd 16-bit chunk. And then we look it up in the reverse, which was stored in our cache. And then we're going to left shift it to mask size, because in this case, 3rd one is just going to move only 16 bits. And the 4th one is similar. We take the 4th chunk location. In this case, we are moving it to 3 times the mask size because it needs to move 1, 2, 3 chunks to get to the first 16-bit chunk. And then we're going to do the lookup in there. Once we do the lookup, all we really have to do is bit mask, end it with bit mask. Why? Because the 4th one is ending up exactly in the first chunk, because 4th one is supposed to be here. Therefore, all we really have to do is extract it by ending it with the bit mask with 16-bit 1, 16 ones. And then we just basically store that value there. I hope this is not too confusing. The whole idea, again, just to quickly repeat everything. If you look at the previous video, I explained how you can take a single integer and then reverse that, right? We have that function in our pocket. Now, what we are doing is building a 16-bit cache lookup. We store the value in an array, meaning that for each integer you give, it basically returns you the integer that's in reverse, right? That's just a lookup. We build that up. Once we build that up, now we can take a 64-bit integer and look up 16-bit at a time and shift those 16 bits in the right place to reverse a 64-bit integer. In order for us to do it, the concept is very simple. What we do is, as I explained earlier, we take these 16-bit chunks right here, and total of 64, we just need to move the right chunk, the first chunk, the least significant bit, 16 bits, moved into the 4th one. Second one moved into the 3rd one. 3rd one moved into the 2nd one, and the 4th one moved into the 1st one. In order for us to get those numbers, what we're really doing is that we are extracting by using a bit mask. Our bit mask is basically a set of ones to extract the value. Once we extract it, we just shift it by using the number of bits that it needs to be shifted by. In this case, because we are doing with dealing with 16-bit chunks, then we just basically do three times the mask size, 2 times the mask size, and a bit, without any shifting. So I hope it's clear. If it doesn't make any sense, or if you need me to clarify something, just put a comment. I'm happy to explain. If you like the video, please hit like and subscribe to the channel. It certainly motivates me to add more videos. I hope you find it useful. Thank you for watching.